So, shell method. Here we go, 6.3. So what do we know about this one already? That our volume is going to come from 2 pi r h dx or dy, yeah. So the 2 pi r is our circumference, right? And h is the height of that particular circumference. And so let's just get a simple picture of what we're talking about. The width of the rectangle, exactly. So there's my rectangle, right? This is my region, just whatever it is. Right? This is the region I'm rotating. I'm rotating about the y-axis. Notice my rectangle is parallel to the y-axis. Shells are parallels. That's what you're going to remember. So r is the distance from the axis of revolution to the rectangle. So that's r. So you can kind of see, if I rotate that around, right, you can see that cylinder, right? So we're stacking cylinders, right? So I got a can, a smaller can inside of that, smaller can inside of that, so much that it creates a volume, right? So dx is clearly the width of the rectangle, and h is the height. So you got to remember, when you're calculating that height, you've got to do upper minus lower or right minus left, right? So I mean, if you can just kind of accept first, you know how we don't quite understand humans, but we accept, and then we can move on. It's just the same kind of thing here. You're going to try and accept the formula, do your best to draw the picture, and then go forward. I love. So I actually think this one might be a little bit easier, but you're going to be basically doing them interchangeably. Sometimes you'll have to use a disc, sometimes you'll have to use a shell, sometimes you can use both, right? So it's a nice challenge to find one where you could use both and see if you can get it. All right, so we went through most of the detail yesterday, right? I'm not really saying much here, but our process is the same. Draw the region, figure out the axis of revolution, draw your rectangle, figure out the variables, draw your 3D image, that type of thing. So, I like number 2 here in the textbook. So I'm gonna take this region of sine of x squared, right, about the y-axis. So I've got y equals sine of x squared, x equals 0, sorry, y equals 0, x equals 0, x equals square root of pi. So the picture, as you saw it, kind of looks like that, right? So we know we want this region, and we're rotating about the y-axis. So right away there, it's telling me if I'm doing shells, and I am here, I want my rectangle parallel to the axis of revolution. I can kind of ghost the whole thing here, right? And it's clearly a pretty friggin' ugly shape, if you think about it. Yeah, I like that thought. It looks like just a blob with the inside was pushed in, right? It's definitely hard to visualize. We might get a nice visual of this one in GeoGebra because it's such a simple, grounded piece, meaning on the x-axis, y-axis. I think we'll get a pretty good picture of it. I'm trying to think of what the hell it is, what it looks like. It looks like one of those. You ever see the door stops on the floor? Yeah. They're like little foam things. It kind of looks like that to me. I mean, maybe it's an ashtray. You can certainly you can see the outside. Yeah, you can see the outside is right. Yeah. What is it? Yeah, yeah, yeah. Okay. So, and I realize here this picture, right? My radius is here, right? That's my radius. Big R, little r, who cares? And the height is just the function, right? The height is just the function, so the height is here. And of course, I can see delta x, right? I can see the width of the rectangle is along the axis, x-axis, so it's a delta x problem. So go ahead. R is just x. Yep, and this is probably the hardest thing to think about, especially when I move the axis. Okay, if I shift the axis somewhere, I got to again be thinking right minus left here. So right, so what's this distance here is arbitrary, so it's x, and then all the way minus the left end point of it, which is 0, right? Starts at the origin. So that's probably the trickiest part. So I'm going from 0 to square root of pi of x sine x squared dx. Right? The radius is x. Yes, you're with me? The distance from the axis of revolution to the rectangle, but as a right minus left. Right? The height of that rectangle is just the function itself, and of course delta x turns into dx. And you can see the volume, right? R is a variable, h is a variable, dx is a variable. Delta x is a variable. So this is a U sub, right? So your first quiz today is a U sub, 2 different ones, and then the second one is by parts. So we'll see if we can do another one by parts here today as well. So okay here, yes, we're okay with this. Let's see if we can get a nice picture of it first. Shell method. I'm pretty sure Brzezinski is the one I've used in the past. No, maybe not. Nope. Damn it. It kind of looks like this shape right here. I can't tell by looking at the cover if I can put the function in. That's just sine x, looks like. Oh yeah, so that's pretty cool. It's showing me one particular piece of a can, right? Every time I move it, that's another. So they're all stacked together to create that particular volume.
It's like Jello.
Yeah, Jello. That's what I was looking for. Yes. Yeah. Yeah. Well, this one looks cool. Let's hope I can do it. Can I put a Yay! And that's cool. It allows me to do two functions, so an upper minus a lower kind of thing. All I want to picture is a picture of my Jello, please. There we go. Thank you. Ugh. Damn, it's pissing me off. All right, I can't deal with it. You play around with it. Did you find one that's good? Is it a little louder for me? Okay. And that's why it keeps quitting on me because it's running the script. Which one were you using? This guy down here. This one. Paramelis law. Let me see, let me try another one anyway. There we go. Can I edit the function? Yes. All right, you tell me where am I? What am I doing wrong here? I'm trying to edit that function, right? And so now I'm editing, but it keeps running away from me. What are you saying I should do? Huh? Anyway, you play around with it. Find one that allows you to put the function in and get a good picture of it. I'm just going to go old school and draw it. All right, let's do this integral. So u is x squared, right? When I'm doing u subs, I'm looking for u as a function, u as an inside, u as a downstairs, right? This one is clear inside, and du is 2x dx. So I need a 2, and I need to cancel it with a 2. So from 0 square root of pi, go ahead. Yep. Sine of u du. So the antiderivative of sine is negative cosine. And we're going to evaluate at pi, square root of pi, and 0. So negative pi times negative 1 plus pi times 1. So 2 pi. Yeah? Again, the setup could be difficult. The integrals in the book are easy, right? Nice. Let's look at let's look at 15. 4x minus x squared, y equals 3, about x equals 1. 4x minus x squared. Y equals 3, about x equals 1. So this one, gosh, I think I can graph this without doing anything. Certainly I know it's a parabola that opens down, and it goes through what, 0 and and 4, right? But I want the cutoff at 3. Yes, I want to see where is it hitting at 3, right? Because that's one of my bounds. So I'm actually interested in 4x minus x squared equals 3. So it looks like x equals, what is it? -3 and -1. So at 1 and 3, I'm hitting, and I've got some region like that. Kind of a weak parabola, but you know what I mean, right? So we're talking about this region here, and we're rotating it around x is 1. So I've got a vertical line for my axis of revolution. My rectangle is going to be here. Of course, I'm going to ghost it, right? So it's my same jello shape. Indented jello shape. But the key here is, what is my distance from, what's my radius here, right? Do you see it? My radius is from the axis of revolution to the rectangle, right? So that is right minus left, which is x minus 1. So are we seeing that? The radius is x minus 1. The height of the function is upper minus lower, right? That's 4x minus x squared minus 3, right? Upper minus lower. So my radius is right minus left. Height is upper minus lower. I think I have everything I need. I'm getting a volume of 2 pi times the integral from 1 to 3, right? From 1 to 3 is where I figured out. And I need my height and my radius. And again, like I said, the setup is tough. The integral is easy as can be, right? Go ahead, race me on this one. Yuck. 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 Oh, brother. Anybody else get there? You ran out of paper? Yeah, don't say paper, right? Kill a tree, pass the class, kill a tree. Let's do one more that's simple, uh, that forces us to be parallel to the x-axis. So, like I'm looking at 17 seems fine to me. So I've got y equals x cubed. I've got y equals 0, x equals 1. About y equals 1. So a pretty easy one to graph, right? X cubed and 1. So we're doing this region, but about this line. So we got the picture, right? Y equals 1 is my rotation. Yes. So I'm rotating this thing around. Pretty kind of easy to see what it's going to be, right? Because I'm going to ghost it here, right? And so, right, pretty simple cat dish, dog dish, whatever. But the key is my rectangle's got to be parallel to the axis of revolution. And this piece is now my radius. Yes, you with me? So that particular height is just some y, but I have to do for my radius 1 minus y. Do you get that? Do you see that? That particular rectangle is at some height, y. In fact, it's at every height in that region, right? I just drew one of them. So that particular rectangle is y up in the air. But I have to do upper minus lower. I got to keep everything positive. So 1 minus that y is my radius. The height of the rectangle is right minus left here, right? So 1 minus x cubed. Oh, but, right, I've got to be solve for x. So x equals cube root of y. So 1 minus y cubed. Y to the 1/3, sorry. You with me? Everybody okay? So I drew the region. I looked at the axis of revolution. drew my rectangle, shells, parallels, figured out my radius, figured out the height of the rectangle. The only thing I need other than that are my bounds, which is obviously 0 to 1, right? I'm looking at the y-axis here. So I'm doing the volume equals 2 pi times the integral of 0 to 1 of 1 minus y times 1 minus y to the 1/3 dy. And now we're racing. Yeah. 28. Yeah. I must have screwed up somewhere. I got a negative volume. Oh, there it is. I found it. Seven, 5. 5 pi over 14. Five pi over 14? Uh-oh. You have you have this piece, right? Or the same as me, better?
Yep.
Nice. Maybe one more, right? How are we feeling okay? We're almost done with chapter 6. So, but I'm expecting you to take up some time in the morning asking for help on things. Please, I want you to be asking for help. Okay? If you're getting everything great, if you're behind schedule, you get to work. You got to put in a couple of hours today, and get some questions for me. Let's do one more. I like one with by parts. I want to try and do. So let's just take sine of x, right? And we did this one before. I'm going to rotate it around the y-axis. So there's my rectangle, and it's pretty obvious that I'm just talking about x, right, as my radius. So I have the volume equals 2 pi from 0 to pi of x sine x dx. Right, the radius to the rectangle is a distance of x. The height itself is sine x, and that's pretty much it. So on your mark, get set, go. We're doing the volume from x equals 0, x equals pi, y equals 0, y equals sine x at about the y-axis. How'd you do? Anybody get there? Still working? Yeah, 2 pi squared. Yep, nice. Nice. You're ready for the quiz today. Right? By parts is not difficult. I think the one I'm worried about is the trig substitutions. Okay? So, what's my quiz schedule like here? Yeah, so that's tomorrow. So try and do that, or maybe come in a little early. We could do a problem or two together. Okay?
Remember which board?
It was day 2, so it is 489 and 490.